Look back at the edge of a black hole, and you'll see 100 of yourself. It's not magic. It's a photon sphere. After 15 seconds, not even light can escape your eyes. Let's talk about a tough topic today. What would happen if I threw you into a black hole? This time it's not science fiction, really based on speculation from hardcore physics. Before I throw you in, let's briefly review what a black hole is. Even the old man Einstein, back then, he described, a black hole is where God divides by zero. He doesn't believe in this stuff at all will really exist in our universe. But you see, humans actually figured it out. When those are particularly large, extremely dense stars reach the end of their lives, they will make a big transformation. I collapsed. There's nothing left. What he created is called the starting point, a mysterious point in time and space, said to have infinite density, so it has unlimited attractive force. General relativity gave us a revolutionary idea. Attractive force is not a force acting on an object. It's just that space-time itself is bent by the mass of the object. The result of the song, he fully explained our planet. How do we orbit the sun? And the planets are kind of orbiting around their homes. Spin. There is no solid black surface inside a black hole. The starting point hidden inside is just too dense. Distorted space-time so badly, forming a deep well with vertical walls. In 1939, Einstein and his old man, he actually published a paper on it. It's not true that stars are greedy for a starting point. It doesn't happen in our universe either. Coincidentally, in the same year, Oppenheimer, it's the famous Oppenheimer, and physicist Hartland Snyder, they jointly published a paper. Forecast. The star could be under its own attractive force. Explore a black hole. Let's talk about it. What would happen if I threw you into a black hole? The amazing thing about black holes is that anything can become him. No matter if you are a star, planets are still little people like us. As long as it is compressed to fit Schwarzschild within the radius, can become a black hole. German physicist Karl Schwarzschild, he was the first to discover Einstein, the person the factory once confirmed. This discovery is both simple and beautiful. Take the sun, for example. If all his mass were compressed into one, a sphere with a radius of only 3 kilometers, hey, he becomes a black hole. And what about Earth? It turns into a ball with a radius of about 9 millimeters. It's about the size of a marble. If we humans want to become black holes, that would be miserable. Has to be compressed to a much smaller size than a proton. Incredibly small. But what if it could become that small? We'd be a black hole. So which black hole should we throw you into? I think it's time to throw you into a black hole. But which one should we choose? We can choose a smaller one. But how boring is that? Let's go with a bigger one. The event world of some black holes, bigger than our entire solar system. That's billions of solar masses. But that's an exaggeration. Why don't you pick one that's closer to home? Sagittarius, a star, the supermassive black hole at the center of our galaxy. You're running around it. It's still us, one of only 2 black holes ever photographed. Now let's set the scene. Suppose you and I fly there. Park the spaceship at a distance from the world. 1 trillion meters in the world. How can I get you to a black hole? When you fall free, I'll stay on the ship and observe. But that's the key. General relativity tells us that people near a black hole, the experience of time may be completely different from others because black holes warp space-time. That's amazing. This effect was demonstrated in Interstellar. To record time, we'll give you a special watch. It can display, from your perspective and mine on the ship, how long has it been? Let's get the watch right. You can start your black hole journey. When your journey begins, you'll see a distant black hole rapidly devouring matter. It was incredible. Matter is heated to extremely high temperatures by friction. If you put this scene in, simulated on a regular laptop, it will take more than 10 years. In reality, the disk will be a bright blue or even white. But in this simulation, he was made orange. It's easier for us to observe. It's only been 30 minutes since you first checked your watch, and you've only completed 0.1% of the journey to the world. So far, I only got 11 seconds longer than you on the ship. This time difference is not too exaggerated. Now we are closer to the black hole, the curvature of space-time around a black hole, creating all sorts of strange visual effects. Light from the black hole on the side or even behind it. It's all bent before it reaches your eyes. Let's check the time again. You've been gone for 2 hours, completed 1.4% of the journey, and I'm 44 seconds ahead of you on the ship right now. This time difference is a bit worrying, but not too outrageous. Shadow of a black hole, dark area in the middle, seems to be growing faster than expected. All because of the attractive force lensing, the light that would have passed by you. It's all bent to your retina. A long time went by. You finally checked your watch again, and that gave us quite a shock. From your perspective, you left about 12 hours ago. But for me, on the spacecraft, I've been watching you float towards the black hole for almost 15 and a half. We are now very close to the black hole. Things are about to get really weird. Before you reach the point of error, you will come to a strange and magical place. If you are frozen in this particular place, in time, then look around. The sight is guaranteed to surprise you. You have reached the photon sphere. This is what we have, one of the strangest places in the universe. In this region of the photon sphere, attractive forces are balanced. That allows photons to orbit the black hole. No matter emits or reflects light, the photon itself is trapped in its orbit. If this light is moving tangent to the black hole, he can orbit. But if the path changes a bit, photons will either fall into the black hole or fly into space. Under these specific conditions, if you just froze at the photon sphere and look around, you will see yourself facing away from your mirror image. You'll see multiple copies of the back of your head condensing. Looking into space, you're actually looking at yourself. It's like standing next to you. No technology is needed all the time. It's all about the distortion of space-time itself. As you continue your journey, you are very close to the world. Now we're past the photon sphere. Black holes are getting a bigger and bigger proportion of your field of vision. It feels like you've been swallowed by the darkness. It's because the darkness twists around you. Show the back and sides of the black hole shadow. Shown as well in flat space-time, the parts that are usually visible to you. You've been gone for 13 hours. In 24 minutes, you're about to cross the world. From the spaceship, I have observed your journey, almost 20 hours. Another 18 minutes passed. You check your watch again. I've been watching you for almost 40 hours now. For you, the last 18 minutes for me. It lasted 18 hours. The last moment has arrived. In 6 minutes, you're about to pass through the world of black holes. You close your eyes Take a deep breath. Check the watch. But he seems to be broken. He shows, I've been watching you fall for an infinite amount of time, but he's not broken. Physics is amazing. I spent decades on airships, watching you slowly approach the world. Finally, I see you become Hung Yi. This means that I have to use an infrared telescope to see you. I will never be able to see you through the world. Even if I could live forever. For you, the last 6 minutes. For me, it lasted an eternity on the ship. This sounds like science fiction, like a daydream, but he was real. He came directly from Ain, from Stan's equation. Now you are in the world. So what happens inside a black hole? Strange thing is, it's hard to see yourself. When did you cross the world? The world, you can look out at the universe, see distant stars, even see our spaceship floating in space. But all those lights are just like you. Gotta run to the starting point. You've passed the point of no return, the point of infinite density. The laws of physics are breaking down. Time has stopped. If you want to escape the attractive force of the starting point, you have to go faster than we all know that's impossible. A common misconception is that if you look out at the universe, intense time dilation effect will let you see the entire future of the universe. History unfolds before our eyes, but that's not true at all. Because of the difference. When you get close to the beginning, you will see the outside. The universe is compressed into a thin little ring. Finally, when you are close enough to the beginning, your feet will be stretched in front. Your body is in Italy, elongated in the process of dough. You and the black hole are one, drifting together in the universe. Until eternity. This whole process is chilling to think about. But I can't help but want to find out. The mysterious celestial body of black holes, it really makes us love and fear.